Alrighty, good morning. I'm planning on doing the contest from last Saturday virtually. I wasn't here last Saturday. So weekly contest 280. I got my coffee here, so good to go. Let's see what happens. Alrighty. Open these guys up and time to shine. Here we go. Okay, make one of them 0. You must subtract num1 from that one or this one. Okay, so this is just the GCD, isn't it? Or wait, hold on. 2 negative, non-negative integers. You must subtract the small one from the big one. Subtract the small one from the big one. Okay, that should be fine. I don't think I want to implement it in Rust though. Okay, 6:16 a.m. Let's see what happens. This seems pretty naive, right? So we have A and B, and we'll just subtract the smaller one from the bigger one until we're done. If, let's see, not A or not B, then return 0. Otherwise, return 1 plus count operations. Count operation. If I can count. I mean, if I can type. All right, count operations, and then A is less than B, question mark. So B minus A, otherwise A minus B. Alrighty. Let's see what happens. Okay, that's 1. That's not right. Okay, hold on. What is going on here? It says 1. Okay, subtract num1 from num2, so you get 1. Oh, wait, hold on. Okay, so that's the first parameter. And then A less than B. Okay, so if B was bigger, let me subtract A from B. Okay, hold on. Let's see, if A is bigger, we'll say that one. How about? So A is bigger, then we'll subtract A from B and then B. Oh, okay, hold on. Do this. Put this guy in parentheses. All right. If A is bigger, then subtract B from A, and then invoke this on that thing. Otherwise, we'll invoke count operations A and then B minus A. Okay, that looks right. Okay, so it's 3, and then this one should be 1, and then we should be good. Alrighty. Yay, okay, 6:16 to 6:18 at 2 minutes. If I can type. Okay, 2 minutes. 2 minutes for a nice, cool little one-liner. Let's do this in the other languages real quick, and then we'll continue. A and B. Return 0 if not A or not B. Otherwise, we'll return self.count operations. A minus B, B, if B is like A is the bigger one. Otherwise, self.count count operations. A, B minus A. Oh, 1 plus that, right? 1 plus this guy, that guy. Okay, and then let's just shrink this up here real quick. Get rid of these. These are kind of verbose. And then let's turn this thing into a lambda. Okay, shrink it up a little bit. Okay, looks good. Yay. C++ is a bit verbose, but it's good to do this as well. So return not A or not B, 0, otherwise 1 plus. If A is the bigger one, we want to do count operations. A minus B, otherwise count operations A, B minus A. That looks good. Ready, cool. And Kotlin, A, B, and we can do this as well. Let's do this, turn it into lambda. Ready. Okay, if A is 0 or B is 0, or return 0, otherwise return 1 plus. If A exceeds B, then count. Oh, I can't do a recursive lambda, right? This is not going to work. I don't think this will work. Oh well, we'll change it back to a function. That looks right. Yeah, recursive lambdas don't work, right? Okay, let's do this. Turn back into a function. Okay, that looks good. Nope. What else? If else unresolved. Oh, must be a typo. Count operations plural. Well, sure is taking a while. Okay, there it goes. Yay. Okay. And all right, we'll try rest. I'm pretty new at rest, so this one's going to be a bit challenge, I think. Okay, so if A is 0 or B is 0, then return 0. Otherwise, we'll return if A exceeds B, count operations, A minus B, B. Otherwise, let's see, 1 plus count operations, A, B minus A, B minus A. Okay, let's see what happens here. Oh, I need a semicolon, I think. Not find function count operations in the scope. Really? I did this in wrong. Cannot find function count operations. Rusty, explain what? What does this mean? Hold on, let me just try this. Does this work? Okay. Do I need a self? Something that doesn't exist, foo. What? An unresolved name was used. I'm not sure if I've tried to do a recursive function in Rust before or not, but I don't know if I need a self keyword. Rust recursive class method. Make a recursive. I don't want a closure that's recursive necessarily, but I want a recursive function. Function. Let's see, class and Rust, is there a keyword self? Oh, okay, so there is a self, huh? Self concon foo? Okay, well, let's see what happens and try self. Oops, self. Self. Nope, it does not like self. In module self, I can't find it. Huh, that's strange. Okay, Rust recursive class method. That's what I want exactly. Recursive methods, Rust, type level recursion. That's how I feel. What the? Show me an example of this, right? Area. Okay, where's the recursive? Type level recursion. Pluck. Where is just an example? It's very verbose. Okay, maybe I'm gonna give up on Rust because this is like super lame. Just trying to figure out some basic stuff. Can you do recursion Rust? Recursion is possible, but it's not really encouraged. Oh, okay. Rust prefers iteration. Right, whatever. We can do this iteratively as well, right? While A is not equal B and oops, A is not equal 0 and B does not equal 0. I just do this. Let mute count equals 0. Return count. If A exceeds B, then let's do this plus count. Oops, count plus equals 1. Okay, and then we'll do A minus equals B. Else B minus equals A. Okay, this is fine, right? This should work. Oh no, it does not work. Immutable. Okay. Let's do this. Let's mute A, mute B equal A underscore B underscore. I think that works to destructure them. Yay, okay. There's my Rust. Alrighty. Find out how to do recursion in Rust. I'm not sure want to or not. It doesn't sound like the idiomatic approach to Rust is to just do iterative anyhow. Okay, let me post this and we'll get back onto the next question. Python 3, Rust, C++. Okay, yeah, I don't want to waste too much time on this. It's a pretty naive algorithm as far as the complexity goes. Already stick these in here, move on. Okay. And Kotlin, and we're good to go. Okay. Kotlin, JavaScript, Python 3, Rust, C++. Okay, that's good. Rust is very verbose. All right, next one. Okay, minimum operations to make the array alternating. Okay, if two away equals num sub I, and one away does not equal it. Two away is equal, one away is not equal. Okay, 10 to the 5th. Okay, so n is 10 to the 5th, so we are looking for a linear algorithm. Let's do a linear scan and fix it up as we go. Every two away needs to be equal. Every one away needs to not be equal. Two away is equal, one away is not equal. Okay, so what are the biggest two away, right? That's what we want to choose. Okay, all right, let's do this. All right. Come up with a game plan. Game plan. Let's see, 6:30 p.m. Find the count of, I guess, count each value in even indices and transform the remainder to the maximal frequency, right? This is basically a greedy algorithm. So we'll greedily consume is, I greedily consume the maximal frequency value, and the cost is the remaining values not equal to that value. That's for the evens. And then the cost for odds is, oh, actually, so maximal frequency, okay, minus odds, which are the same. It might not be quite this naive, but we can dig into it and play around with it for a little bit. If we have to change every even to 3, hold on, let's mess around with this for a little bit. Grab these. All right, so the game plan here, my array equals 6. This one's okay, okay, not okay. The even indices, and this one is okay, okay, and then not okay. So how many do we have to change? We're saying ends up being this before and it's after. Oh, it has to change to a 1? Not equal n sub I. Why? Is that a typo? Wait, no. Oh, it does have to be, okay, so it's not equal to the same, but it has to be interleaved. Okay, it does have to equal the same. Okay. Ah, I see. Okay, so there's two choices, right? So, okay. In the end, there will be two values and only two values. Optimally choose those two values, right? I mean, that's pretty much it, right? Okay, so we'll count the frequency of odds, right? So game plan, count frequency of values in even indices, and count frequency of values in odd indices. Then cherry pick the optimal value for each. I think we also have to be aware of corner cases. Okay, let's start implementing this and see what happens. 6:35, begin implementation. Don't want to get into the analysis paralysis. Implementation begins. All right, let's do this. Let's shorten this up here real quick with the using declaration. Myself a little space to work with. Alrighty, here we go. Okay, so minimum operations will be the count of those ones and the count of these ones. You have to alternate them to not be the same value. Okay, so we'll have two maps. Let's just say I have A and B, or even odd. All right, so these will be the counters. Do this, map A, map B. Okay, for I0. Then. Okay. M sub A sub I. Oops. I plus equals 2. Plus A. Already. No, we don't need to. We don't need those little squigglies. That's fine. All right. For I is 1. This is cool. Yeah, just stick it on the line. That's fine. All right. I is less than N. I plus equals 2. Plus B sub A sub I. Okie dokie. I want the maximal frequency of this, maximal frequency that, and then swap them. But what if the maximal frequency is the same? Like we have the same value. You can't do that. So that's the corner case, right? One of the corner cases I can see, right? Corner case. What if the maximal frequency value of even odd indices is the same? Then we need to choose a second best for, right? We need to optimally choose the second maximal frequency value in this case. And this also, this optimal choice, right, is dependent upon the quantity, right? Quantity of even odd indices. So if the cardinality n of the input array A, if it's even, then there's an even amount, right? An even amount of even odd indices. However, if there's an odd amount, right? Odd, right? If n is odd, that means there's one more even indice than odd indices, right? This means there exists one more even indice than odd, right? I think so, right? So if it's a n equals 1, then there's one even index, 0, and 0 odd index, right? N equals 3, there's 2 even index, right? 0 and 2, and 1 odd index at 1. N equals 5, and there's 4 even index, 0, 2, 4. And wait a sec, there's not one less. Oh yeah, there's three and then there's, okay, yeah, there's two. Okay, I'm confusing myself now, 1 and 3. There's 3, I wrote that wrong. 3 even index and 2 odd index. Right, okay. Okay, so in this case, we'd want to cherry pick. Right, the upshot is this, upshot, cherry pick, even index, or maximal frequency value, and for odd index, we use second maximal frequency. Okay, other than that though, I think it's pretty straightforward, right? So let's find the best and second to the best for each. Okay, the first best and the second best. Okay, so let's just create a lambda function that can do this for us. Take those things by reference. Best and the second to the best. Okay, actually, let's pass in the map. This will be our map of counts. And we want to return a pair of best and second to the best. Okay, so let's do, actually, maybe we should do a sorted map then if you want. I want it sorted by value, not by key. This is easier in Python since I can use a counter and most frequent. All right, let's just go with what we have. Okay, so we have a map reference and we want to sort it then, right? Sort m.begin, m.end. Wait, hold on. Let me just an array of, do you want to transform it to an array of pairs and then sort that? Yeah, okay, let's do that. An array of pairs. Using pairs, pair, using pairs, our pair. Okay, so our pairs, and then copy m.begin to backend server, the array of pairs. Actually, I wonder if this will work without the lambda. Just copy them straight up, sort. Okay, so sort each of these pairs based on the second. A.second. Nope. A.second. I want to sort them in descending order. Okay, so then first and second. Okay. First most frequent, second most frequent. All right. That size is equal to 1, and you'll pretty much have to return a pair of the same thing. Turn a pair. value based on the sorted key. Otherwise, I can return, let's return this. Let's return a pair of a sub 0, a sub 1, sub 0. I need to return the value of each of those. Okay, so auto, the two best from the first and two best from the second. Okay. Okay, we just call it U and V, X and Y. Okay, so you know all the different cases which can occur. This one's kind of a pain in the ass the way I'm doing this, but whatever. Okay, let's go with it. We can fix it up later. Okay, so which one is most frequent? U or X? We want to cherry pick U. So if U is bigger or equal than X, then we definitely want to choose that one. I count all the values that are not equal to that. N divided by 2. K equals N divided by 2. Cost. All right, so we can just add up the cost. Oops. Cost plus equals K, which is N divided by 2. So when N is odd, say 3. 3 divided by 2 is just 1, but I want it to be 2, right? I want it to be 2. There's 2 even indices. Okay, so if N is odd, then there's K plus 1 even indices, otherwise they're just K. That's when we take the first. I want to cherry pick that one. U is greater than X, right? The first most frequent value. Oh wait, hold on. I want it to. Oh crap! Actually, I'm doing this one like horribly wrong. I think I need to come up with a better approach because this is getting like way complicated. Remember, right? Hold on. Let's do this. Right, this is just getting complex, and I don't know for good justification or not. Remember KISS, right? Keep it super simple. And this is getting really complex. It's not getting simple at all. Right, so how can I do this a little bit more easy? Maybe what I can do is just split it into 2 separate arrays. Rather than considering the even and odd indices, and then transform those arrays to 2 separate and distinct values. Right, I think that probably makes more sense. Hold on. No, I don't. Yeah, I don't. It just doesn't feel quite right. It's just getting hairy really quick. So I'm thinking it would be easier in Python, but it's still doable in C++. Okay, so let's come up with this game plan then, right? Let's do this. Game plan. Take input array A and then transform it into B and C, right? These will be even, odd, index values. All right, let's just do this. So 2 separate arrays. And then these values in B have to be different than the values in A. So every value of B must be the same, right? And then same thing for C, right? Every value of C must be the same. And the values of B not equal values of C. All right, so let's just do this for auto. Okay. B, C, copy if a dot begin, a dot end, back insert to B, do immutable lambda, -1. Not gonna use it. Let's bring in A as a reference. Turn ++ I and 1, 0. That means it's even. All right, so these are even. And these need to be odd. So hold on, copy A. And then I'll have to go into C. Okay. Now there's either, okay, there's two use cases. The cardinality of B equals the cardinality of C, or the cardinality of B equals the cardinality of C plus 1. And this occurs, right, when in the cardinality of the input array A is odd. Right, there's one more even than odd index. Okie dokie. And now what? We'll fix up B first, and then we'll fix up C next. Suppose you can consider the opposite too. Okay, let's do this. Fix up B, then fix up C. See what that cost is. And then do the reverse, fix up C, C, then fix up B, right? And also see what this cost is, right? Same thing. And take the minimum of those two costs. Yeah, I feel like there's still going to be some weird corner cases here. This one's just, it feels tricky. It feels a bit off. Right, let's get something going here. Fix up. Okay, if we're going to fix up B, then how do we want to fix it up? We do still want to take the count, right? Take the count to the most maximal frequency value. Let me ask myself a question though, real quick. When is it advantageous? When is it disadvantageous to cherry pick the maximal frequency value for even index? This occurs, right, when the cost of flipping odd index to another value exceeds, right, exceeds the benefit of this cherry pick, isn't it? I think. Okay, and then I guess we'll choose that, or we'll figure that out when we fix up C first, then fix up B based on that, right? Fix this to that, otherwise fix that to this. Those are two choices. The ultimate and penultimate frequency values. Let me ask myself another question. What is the absolute worst case? I think all values are different. When all values are unique in A, right? We have like 1, 2, 3. Let's say these are the indices, and n equals 5. And we have to pay the cost of 3. N is 6. Still the cost of 3, isn't it? 5. No, it should be 4. 1, 2, 3, 4. Okay. The worst case is n minus 2. Right? That is all values, right? All even index values except 1 need to be changed. Similarly, all odd index values except 1. So uniqueness is not beneficial here. We want redundancy, and redundancy is beneficial since we don't have to plot those values, right? Uniqueness is costly, while redundancy is beneficial. Okie dokie. Can I count the unique ones then and use inversion? If all of them are unique, then what does that mean? We have to pay the cost of all of them minus 1. all of them are the same value. That's a good thing. So now would be probably a time that'd be more beneficial. Just write this on paper, start doodling and exploring the studio space a bit. But try to just keep on at this just by typing. So these are the corrections, is 313 corrections. And how is that based? All right, so even index, we have 3 next values, 3, 3, and 4. Odd index values, they're all unique, 1, 2, and 3. The cost here, k minus 1, where k is the cardinality, the odd index, odd values. And the cost here, whatever is not the same, is 1, because there are 2 redundant values. There's k minus the quantity of redundant values, k minus the quantity of maximal redundant values. In many ways, I feel like I'm still overthinking this. Like, is there a simpler way to do this? So inversion is beneficial. Right, so what if we turn it into a set, right? Transform into a set of unique values and use inversion to simplify. Right, so our unique set would be 3 and 4 for this, and the unique set of the other one is 1, 2, 3. Unique values, 3 and 4. So there's 2 unique values. There's 2 unique values. We know that one of them has to change. It's not the unique values that matter so much as the count. The maximal frequency is still what we want, right? No, we still want to cherry pick, right? Greedily cherry pick best, I think. Right, I mean, there's 2 3s. I think we want to take advantage of that. Maximum frequency. Okay. So given our array, which is the odd or even indices, find the maximal frequency as the best count. Oop. Okay, I think probably now is a good time to actually move on. This one's taking quite some time. I started at 6:30, it's 7:05 already, 30 minutes in. Not really making much progress. Slowly working through it. Okay, well, map M. Okay, I'll go X and A. M's of X. Best equals maximum of best. And that frequency. Okie dokie. So I know the maximum frequency of that is 2. First would be that size minus F sub B. So that's the cost of that one, plus the cost of changing the second one to every other value except for the one that we chose. Okay, so let's do this. Do take and then best. We want to take the best pair. Oops. Make pair 0, 0. Take the best. Take will be the value that we take, and the best will be the best, the maximum frequency. If best is less than that, then we'll say best equals it. Take equals X. Best is M sub X. Okay, so we'll turn a pair of the value and the frequency of the value. Okay, let's do first and then second. Pair 0, 0. Okay, so then let's do this. Take best equals F sub B. Then we'll do the same thing for C, even in odd indices. So here, take the best of that. Okay. First and second will be candidates for the best overall. Okay, so first equals B dot size minus best. All right, so take the quantity of the same value, subtract it from the cardinality of that, that's our cost. Flipping the ones that are not equal to that value. And then plus how many values in C are not equal to what we took. Count if C dot begin, C dot end, turn X does not equal what we took. That's the cost of flipping every value in C to the value other than X. This is getting really tricky again. Take B, best B. Take B. Cannot equal that, but then we don't want to count the redundant ones. This is getting complicated again. Remember, right? Keep it super simple. There's got to be an easier way of doing what I'm trying to do. Let's just come back. Let's come back. All right, let's come back. Let subconscious work on it. Even though I don't want to, I'm not really making progress. I'm starting to spin my wheels. Spin. Right, 7-Eleven. Oh, that 41 minutes. I have a lot of room for improvement. Right. Improvement. Removing minimum number of magic beans. See how much time we have left. Okay, so we still have 30 minutes. The first one didn't take me very long. So let's try to reset and let's hit it again. Let's C++ is verbose. So try. Actually, let's do JavaScript. JavaScript's cool. All right, 7-12. Let's try to brush off that last one. Keep focusing forward and see if I can try to get another one. Okay, yeah, don't get discouraged. An array of possible integers beans. Each integer represents a number of magic beans found in a particular magic bag. Remove any number of beans, possibly none. Each bag is just a number of beans, and each remaining non-empty bag still contain at least one bean is equal. Number of beans, okay. Once a bean is removed, you're not allowed to return to any of the bags. Return the number of magic beans you have to remove, okay. You must remove one bean from the bag with only one bean. Why? Equal. Remove them till they're equal. If the accumulated sum of all the values is less than the one maximal value, it looks like we return that, right? 2, 7. What is the best solution here? Remove. So we can only go down. We cannot go up. Okay, be right back. Okay. Alrighty. Back to this. Okay, so it needs to go down to 0 or it needs to go down to the minimum value. 0 or minimum value, 0 or minimum value, 0 or minimum value, 0 or minimum value. Okay, so we know it has to go to 0 or minimum value based on what's the maximum value. The maximum value here is 10. So yeah, the cost of going to the minimal value 2, right? If we moved all these to 2, what would that cost? Right, if we move this to 2, it costs 2. This one to 2. Oh, 2 is 0. Move this one to 2, it costs 8. Move this one to 2, it costs 1. And it costs 0. Change all values to minimum value. That would cost 9. It's not quite as naive as just looking at the biggest one, though. Change all values except for maximum to 0. Let's hold on. So cost 2, cost 0, 3, and 2. So cost equals 7. Optimal. Optimal value. Okay, so anyhow, n equals 1e5, 100,000. So we're looking for a linear algorithm. So I think we can do some okay, so the values can only go lower, right? We can only reduce the values. Reduce the values so that they're either the same or 0. If they're going to be the same, then they're going to be equal to some minimum value. This one, maybe I can start with brute force and then optimize. Each value is from 1 to 100,000 inclusive. So if we zero them all out, it's the accumulated sum of all the values. that'd be probably the worst case, right? So I have a question like, what is the worst choice? Is zeroing them all out cost the accumulated sum of a, we don't want to zero them all out, all right? We want to find some optimal value where they can go to rather than all the way down to zero, right? So each value x of the input array A, case 1, goes down to 0 at the cost of x, or otherwise it goes down to y at the cost of x minus y. All right, so next question is how to find optimal y. This should be some existing value in A, which is less costly to arrive at than 0. So I do believe it makes sense then to sort the array, some pre-processing via sorting. So if they sort this guy, then what? Equals this guy, then sorted, it's 1, 4, 5, 6. And can I pre-process this in a way that's beneficial to know that 4 is the value that we want to arrive at? 1 we want to zero out. At index 0, what does it cost for all other values to go down to this value, right? Or 0 if all other values are less than, right? So to go down to 1, it would cost all the ones above 1. So if 1 is here, or if you think of this as like a graph, 2, 3, 4, 5, and 6. One, 2, 3. So this costs 3. This costs 4, and this one costs 5. Right? It's monotonically, or the offset increases based on the value. Okay. It's going to cost 0. Okay, so then if we choose index 4 or index 1, okay, then we zero out all seen values. That is the accumulated sum thus far and reduce to the left of current I pivot index. And then we reduce all values to the right, the current I pivot index till the value a sub I. Okay, so we should be able to know that by pre-processing, right? If we do prefix sums, then we should be able to calculate an O of one time, right? Using prefix sums, we can calculate a relative sum based upon absolute sum in O of one time. Right, we do that in constant time. So we can know that that's equal to 11, and the cost of that is 11 minus 8, which is 3, right? So 5 and 6 equals 11. And then we subtract 2 times 4 equals 8. So it's 11 minus 8 equals 3. Okay, so that should work, right? So the game plan is this game plan. Sort the input array A, right? Sort A, and then do prefix sums, prefix suffix, or sums, yeah, sums to derive suffix sum and O one time. Okay, and then also keep track of accumulated total so far. These are zeroed out candidates. Okay, that sounds good. And then keep track of the best at each pivot possibility. Oops. Okay, and its length, and then sums equal copy of A. Oops. Plus that in I s of I plus equals I minus 1. Okay, so those are prefix sums, and then I equals 0, I equals n. Okay, these are our candidates. Okay, so our candidate will be equal to that value a sub I. All the values to the left of a sub I will be zeroed out. That'll be our zeroed out total sum cost. Cost equals T. All the zeroed out items to the left plus prefix sums to the right minus what we're at, right? So the amount of items to the right is n minus 1 minus I. Minus 1, all right? One less item to the right, non-inclusive of where we're at. How many items are there to the right of where we're at? That's what I'm asking, right? N minus how many items are to the right? Okay, so hold on. If we have this, right? This guy equals this. and we're at index I equals 0, n equals 4, I is here, and how many items are here? There's 1, 2, 3. N minus 1 minus I minus 1. Right? Does that work out? N minus 1 minus I minus 1, right? N minus 1 is 3. No, it's n minus 1 minus I, right? N minus 1 minus I. Right? 4 minus 1 minus 0 equals 3. Okay, and then when I is 1, does this equation still work out? Hold on. Let's see. So it should be 2, right? N minus 1 minus I, right? It's 3 or 4 minus 1 minus 1. 2. Okay, that does work. N minus 1 minus I. Great. Okay. N minus 1 minus I. Items to the right. So hold on. If n is 1, n equals 1, right? A equals just, let's say, right? Index 0 is I. N minus 1 minus I, right? N minus 1 minus I equals 0. Okay, so that does work out. Right? 1 minus 1, it's basically 1 minus 1 minus 0. Okay, yeah, I don't know. I still don't trust myself, I guess. Leftover negativity from that last one give me a hard time. Okay, so that's how many items there are, and that's going to be multiplied by current A sub I. A sub I times that, and then this whole thing is going to be subtracted by this. The prefix sums to the right is S sub oh wait, hold on. If I do prefix sums, if we build them on top of each other, hold on, let's do prefix sums in a way that makes sense. 1, 4, 5, 6. This is 1, 5, 10, 16. 2, 3. So then it's S sub I minus 1, S sub J minus S sub I minus 1. So let's do the prefix sums in the opposite direction. So instead of J down to I minus 1 non-inclusive, or I non-inclusive, it's easier to go I to J non-inclusive, right? Just think of it that way. Do it in the opposite direction. 1, 4, 5, 6. Then we'll have 6, 11, 15, 16, 0, 1, 2, 3. And then I to J non-inclusive would then be 0, 1, 2, right? So if I want the sum of 5 and 6, then it's S sub I minus S sub J plus 1. S sub J minus 1. That's J plus 1, so that seems to be 0 at the end. Okay. A sub 0. Okay, yeah, let's do this then. S equals array of n one, and this is easier to do, right? Fill with all zeros, and for I is in, I S sub I, let's go to I plus one. Okay, that'll make it easier on myself to calculate prefix sums from right to left and left to right, put the base case over on the right hand side. And then we'll do S sub I to J non-inclusive. S sub I minus S sub J non-inclusive in. Okay, so that's the cost is sum to the right of I plus one. To the right of I, right? I believe that works. So this is the candidate. This is our candidate, is the ongoing total to the left, which will zero out, plus the prefix sums of stuff to the right, reduced down to A sub I. Right, okay, that looks good. Best equals the best candidate. Okay. Let's see what happens. Not a number, uh-oh. Not looking good. Okay, let's just print out our candidate, say. I plus one, N. Let's do this, the ith candidate. Okay, debugging time. Okay, so hold on, let's keep track of where we're at. 7:12, 7:37. It take about 25 minutes for game plan plus initial implementation. I think contest is almost over, actually. Yeah, 7 minutes left. Okay. Might have a clutch move. Let's see what happens. 7 minutes. So what are our candidates then? Not a number, not a number. Uh-oh. T is 0, S sub I plus, let's print this. What is S? Well, that's not right. Still, I equals N minus 1. No. Ooh, okay, it's A sub I. Okay, that looks right. Okay. The candidate is 0 at 0? What? Oh, I need to sort A. Hold on. Yeah, A dot sort. Sort it in ascending order. That looks right. The cost of moving everything down to 1 is 9. So 3 plus 4. Why, that's not right. Is it? One. Hold on, get my music going. Let's connect. Okay, try not distractions. So the first candidate should be prefix sums of that, right? No, that's not right. Is this right? Like 4? I don't know. Let's see what this one comes up with. Oops, hold on. Sample. Yeah, these answers are too good. It's not quite right. Okay, so this is pretty close, but it's not quite right. 3 minutes. The total ongoing totals to the left, and then the prefix sums to the right. A equals 1, 4, 5, 6. So when I equals 0, then what? Total equals 0, and the accumulated cost to the right would 3, 4, and 5. 3, 4, and 5 is 12, right? Cost is 0 plus 12. So it should be 12. I'm coming up with 9, so it's not right. $13 is not right either, right? Cost of this one should be 3, 4, and 5, right? 7 plus 5 is 12. I need to sort A before I calculate the prefix sums upon it, right? Sort A, then do the prefix sum. That looks right. Okay, what happened? As for initialization, I already sort it, then do the prefix sums upon it. Sort prefix sums. Okay, that looks right. And then take the best candidate, 4 and 7. Okay, that looks legit. Yay. Oh, 36 seconds left, just in time. Oh, that was cool. That was tricky, but doable, I guess. I had a lot of negativity from the last one. Let's see, 7:44 a.m. AC, yay. Okay, so to do upsolve Q2, and I haven't looked at Q4. I ran out of time, but that was cool. I got 2 out of 4 is not too shabby. I'll catch you next time.